Hello everyone, I hope you had a great week. Today we're going to continue what we were doing last week. I'm sorry about 5 minutes late, but today's algebra session took a lot longer than expected, but we finished the unit, so we're fine. Now let's get to it because we have a lot to do. Really. So let's do 3. You decide to write a paragraph proof to prove that diagonals of a rhombus are perpendicular. His incomplete proof is shown below. Let's do this. Oops. 1 second. Okay, now. Since JKLM is a rhombus, okay, JM equal to JK, okay, because JKM is also a parallelogram, MN equal to KN. Because, okay, now they're saying about parallelogram, they said diagonals of parallelogram are congruent. Diagonals of parallelogram visit each other. That's the two options. Now we're talking about MN, which is this. Okay, I'm gonna make this. Talking about MN and KN. So we're seeing that they are half of that diagonal. So we're not talking about two different diagonals, so we don't care about this one and this one. We're talking about the diagonals beset each other. So the two half, so this half is going to be equal to that half, and then this half right here is going to be equal this half. You are not talking about and the other hint is that you're not talking about two complete diagonals, and the diagonals of a parallelogram are not congruent to each other. Now let's see. By the reflexive property of congruence, Jn equal to Jn. So let's make sure what we have. We have this side congruent to this side. We have we established before this side congruent to this side. Then we established that this side was congruent to itself because the reflexive, so we have side, side, side. So the two triangles are congruent by the side, side, side angles theorem. So here we have SAS, so it's not. And we see that D is going to be our option because it's the only one that has not been like discard. Now let's make sure. Let's read reason 3. So J and M is congruent to J and Q by CPTC, which is congruent par to congruent triangles are congruent. So J and M is congruent to J and K. Now, by the, okay, J and M and J and K are supplementary. So this is the linear pair theorem, which is that two angles or more that are over a line add up to 180 degrees, which is the same as saying supplementary. So we have it here, and we just confirm that D was our answer. Now 31. This is a bit more complicated, but let's see what we have. Complete the following proof that the diagonals of a parallelogram bisect each other. So, ABC is a parallelogram, that's the given. Opposite sides are parallel to each other by the definition of the parallelogram. And then I have that BAE, BAE, and DCE are congruent. Why? So, let me draw this. We have this side here. We have this side right here. It's parallel. We just established that it is parallel because of the definition of a parallelogram. And then we have this diagonal here. Now, as you can see here, this makes a Z. which means these are alternative angles, specifically alternate interior angles. You can see the theorem here. So I'm just gonna do this because it's the same theorem. Now, here we're looking for another thing. Let me see. Here I have an angle. I'm probably going to look for another alternate angle theorem, or maybe corresponding angle. Let's see what we have. So we have angle ABE. So ABE, which is this angle right here. And then CDE, this angle right here. And as you can see, by this line, we make a Z. Now the Z is to the other side though, which is also means alternate angles theorem. So this is also alternate angles theorem, but the ones that we're using are ABE, CDE. So ABE, CDE is what goes here. Now we say that opposite sides of a parallelogram are congruent. So let's look for a side. We have AB congruent to DC, so this is AB, this is DC, so yeah, okay, wait, I'm gonna delete this. So this is AB, this is DC, okay, that's true. This is AD, and this is BC, which is also true. Opposite sides of congruent of a parallelogram are congruent. So this is going to be my statement for here. Now I'm looking for ASA, triangle congruence theorem. So ASA, what we know. Let me put in there what we know. We know angle BAE, BAE, BAE congruent to this one, and we know this angle is congruent to this angle, and we also know this side is congruent to this side. That's what we have established up to now. So I'm looking for these two triangles. This triangle right here and this triangle right here. So let me see, ADV, no, that's not what I'm looking for. ADV is this whole thing. I'm not looking for the whole thing. What about ABE? ABE, okay, and CDE. Okay, that's exactly the triangles I'm looking for. So that's going to be my answer. And that's what goes here. And we just finished our proof. Now, let's continue. 32. He has Mashenka has written an incomplete proof of the congruence of opposite sides of a parallelogram. Her work is shown below. So the ABCs of parallelogram is given, and we know that the AB is parallel to CD and ED parallel to CB by definition of parallelogram. And now why ABD is congruent to CDB, and this one, which is ADB, is congruent to CBD. Now, as you can see here, this is basically saying as before, these two lines are parallel. This one is parallel but to this one we established before, and we have this here, the second line. So we have the C, like this is making the C. So we have a C right here, and we have another C right here. So we are looking for alternate anterior angles theorem. So either they are not corresponding, they are not corresponding. So we have either A or C. Now I'm going to look at the other one. We have dv and d equal to dv. So this is obviously a reflexive property because it's the same, it's the same uh, it's the same side, just reflected over itself. So the reflexive property. So okay, we are left with the same two options we had before. And now we're looking for ASA congruence. So let's check. We have two sides. We have TV. Okay, let me check. Okay, let me delete this. Not letting me. Okay. We have DV. So we can say if the triangles are DVC and DVA. So DVC, DVA. So let me check this one. This one is ADV. ADV, okay. And CBD. Um this one is okay. It's the same triangle using different order. Now, let's see something. We know that D goes with B. So I'm going to make sure that D here goes with B here. They're in the same side. Ooh, now let me do this. I'm going to make sure that A goes with C. So A goes with C. A goes with C. And then that B goes with D. So B goes with D. B goes with D. As you can see here, they are not in the correct order. I put in the color so you can see better. And here they are in the same order. But this one is wrong. That's not what we need. And our answer is A. Now, the figure below shows quadrilateral with parallels and congruent segments as marked. Prove that RU bisects SB. Okay. What is the appropriate statement for step 2? So we have that QS, okay, angle QSU, KSU, so KSU, this angle is congruent to KPR. We also established that RB is parallel to SU. Okay, I'm trying to draw this right. Okay, more or less. You get it. You see here the second line again, alternate interior. That's just it. Most of the time it's going to be alternate interior. Just like if you don't know, it's better to know. I would recommend looking at this because you're going to see a lot. But if you have no idea for 1 second, for one question to why those angles are equal, you can just guess it's alternate interior. Unless you know it's not alternate interior, then I don't know what to tell you. But most of the time, that's what we're going to do. So you see here, alternate interior angles. This is going to be your answer. Now, B, statement 3. Let's check. Is angles SUK, SUK. Here's this angle. And then KRB. Again, it's the same thing. Again, the C, you're going to do this, which is Z. So it's again alternate interior. Alternate interior. Now, what is the reason for the statement in step 4? So step 4. Okay, now this is what we have. We have this side SU congruent to RB. We have established it here. And we have, oh, here, sorry, that was here. And we know that the part of angle, so I can see here this angle, side angle, and here angle, side angle again. So I'm looking for ASA, angle, side angle. And that's what we see here, part B. Now part D, so we have two sides that are going to be established as equal. So it's going to be SK equal to VK. So that's for CPTC. Corresponding part of congruent triangles are congruent. Corresponding sides, like they are sides, like first they are side, they are not angle, and then we are looking for as are congruent triangles. We established that they are congruent or similar. This is the sign for congruent. This is the sign for similar. So since they are congruent, we are not looking at similar here. And our answer is C. And let's see 34. Given isosceles trapezoid ABCD with AB parallel to AD, BC parallel to AD, prove that A equal D and B equal BCD. Okay. Given isosceles trapezoid ABCD with parallel ABC A to AD, construct CE parallel to AB. So we know that CE is parallel to AB. Now, then ABCE is a parallelogram by definition. Yeah, the opposite sides are parallel to each other. So AB congruent to CE. Yes, because it's a parallelogram. So congruent as well. Because AB is congruent to CD by the definition of isosceles trapezoid, you know that AB is congruent to CD as well. CE congruent to CD by the we established that this one is congruent to this one by the definition of a parallelogram. Then let me do this. After that, we establish that this one is congruent to this one by the definition of a trapezoid, isosceles trapezoid. Now, based on that, I can establish that this is congruent to this by the transitive property, which is that I like taking the property from one side and putting in the other. Like, for example, I have in easier term, I have AV equal to CE, and then I have AV equal to CD. Then if it's like I can cancel out this. I can say that CE equal to CD. Every time that I can cancel out something like this is a transitive property, specifically for sides or angles. So let me check this. I see reflexive here, I see symmetric here, and then transitive. So I'm fine with that. Now, let's check. So angle CED, angle CED, congruent to D by the definition of angles, the base angles theorem, which is basically, isosceles triangles, the two sides are equal, the base angles are equal. So, and A is congruent to CED by the, okay, and we don't know. So first I'm going to delete all the other stuff for now. So we're trying to compare these two. Now, we know this side, parallel to this side. And I can do this. I can say this is going to be my second line. Based on that, I can see here, this is like an F. This is like an F. And every time you have an F, is a corresponding angles. And corresponding angles are equal. So I can say that this angle is equal to this angle by the corresponding angle theorem. So I have here the corresponding, and I have here the corresponding. So either way, I had the answer, but it's better to know it. Now let's check for the last one. So A, A is congruent to D. Okay, now we're going on by D. This is basically what I explained before. Also, reflexive property, I see here, reflexive property is only when you say AD congruent to AD. So it's when you're saying the same thing congruent with itself. That's the reflexive property. So we know this cannot be right. So either way, I'm saying now that this angle is congruent to this angle. So reading in easier terms, as I said before, I had that angle E was congruent to angle D. That's what I had. Then I had the angle E was equal to angle A. Now, if I take out these two, if I cancel out those two, I get that angle D equal to angle A. And why is that? That's because the transitive property. And that's what we have here, transitive property. So D is our answer. Now, logic. Okay, these exercises can be a little bit tricky. Logic is not for everyone. It can be like complicated to analyze. So let's get to it and see what we can do. Given the biconditional, two lines are perpendicular if and only if they intersect at right angles. Write the conditional statement that could be written from the biconditional. What is the converse of that conditional statement? So, first, let's explain the difference between a converse, the conditional statement, inverse, and everything about that. So first, I'm going to draw it at the bottom, I think. Yeah. So I have the condition. I have the converse. Oops. Converse. I have the inverse. And I have the contrapositive. So the condition is going to be if Q, comma, then P. Now the converse is you saying if P, then Q. It's just changing, like putting the last part at the beginning. Now the inverse is going to say if not Q, then not P. So it's just saying no, like if they say no to whatever they are like establishing. Let me put this a little bit down. And then the contrapositive, if not P, then not Q. It's just putting invert, like putting like a converse. So it's like reflected at the end from the thing that was at the end, put it at the beginning, but also saying the not. So the contrapositive is just both the converse and the inverse together. So based on that, I'm going to go to my exercise. So they're telling me to write the converse, and converse is just the the part that is at the end, at the beginning. So I will say if like if they intersect, like I will say at the beginning, if they intersect at right angles. So this is the beginning. Then the two lines are perpendicular. And because it's the converse, but saying the last part at the beginning. So the conditional statement, our conditional statement is just the same as it's here. So if two lines are perpendicular, it's in the same order. So no and no is if two lines are perpendicular, then they intersect right angles. In the same order, that's the conditional statement. Now the converse is just flip it. I say this say if two lines do not intersect at right triangles. And now we see that this is not what we're looking. It's saying do not. It's saying negative p or not p. Like not perpendicular, not intersect. So that's not what we're looking for. We're looking for keeping the meaning, just flip it. So if two lines intersect at right triangles, okay, that's our beginning for the converse. Then they are perpendicular, that's our end. And this is what we're looking for. Now let's see theory 6. Rewrite the definition of congruent segments of single biconditional statement. So if two lines segments have the same length, then they are congruent segments. So let's see here. Now, as you can see here, they say biconditional. And biconditional just means, biconditional goes with if and only if. If it does not say if and only if, then it is not a biconditional. So this is not a biconditional, and this is not a biconditional. Now let's see. Two line segments have the same length if and only if they are congruent segments. Let's see here. If two line segments do not have the same length if and only if they are not congruent segments. Okay. Now, as you can see here, this is negating, this is denying. This is not what we're looking for. We're looking for by the same. Saying a single biconditional statement is just the same thing saying if and only if. It's the same thing we have. And as you can see, C is the same thing we have, just with the if and only if in the middle. So C is our answer. Now, 37. Rewrite the following definition as a biconditional statement. So again, we're looking for an if and only if. This does not have an if and only if, and this does not have an if and only if. So let's say now, the point of this is the definition. The point of a segment is the point that divides the segment into two congruent segments. Okay. A point is the midpoint of a segment if and only if the point divides the segment into two congruent segments. Okay, I like that. This is basically what I just said. Now, the point divides the segment into two congruent segments if and only if the point is a midpoint. Okay, now as you can see, they are flipped. One of the two is flipped. Let's identify which one. So we start here with the midpoint. So we start with the midpoint. Oops. And we end with congruent segments. We end with congruent segments. And here we start with congruent segments. So as you can see here, this is not what we're looking for because it's flip. So the answers are flip. So this B, let me do another color. B is our answer because it's the one that is not flip. Now let's do 38. What is the inverse of the statement? Okay, remember inverse is in the same order but denying whatever it says. So let's look at this. Is a parallelogram, has a right angle, then the parallelogram is a rectangle. Okay, let's see this. We are looking for a knot. So here we do not have the knot. Here we do not have the knot. So it's either B and C. And now we're looking for the same order. So first right angle, and after that, rectangle. So as you can see here, B is flip. So B is not our answer because it is flip. So our answer is going to be C. It's in the same order and it has the knot. Now let's say 39. What is the converse of the statement? Now, the converse, remember, converse is the same thing but flip. It does not have the don't or not. It's the same thing. Just the end at the beginning and the beginning and the at the end. So congruent, wait, first let's take away the one that have the don't. So this have the not, this have the not. So if two angles are congruent, then they have the same measure. So first we're going with angles. So here, let me check. Angles. Oh, wait, never mind. First we're going with congruent. So here's congruent. Okay, this also have a don't. So I think this is pretty straightforward. But either way, has the congruent, then we have measure, same measure. As you can see here, it has basically the same thing, it's just flip. It does not change the meaning, it does not say anything, just flip the statement. So C is our answer. Because we're looking for the converse, remember? Converse is the same thing but flip. Okay, let me do something. So Q. So Q, 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 Q. And then this is going to be P. So you can visualize it better. So converse is just the inverse. And inverse contrapositive, it say also the not. Now let's see 40. What is the contrapositive? Okay, contrapositive. Remember, contrapositive is both inverse and converse. So it's going to be the end at the beginning. It's going to be flip, and it's also going to be a denying of what it's saying here. So if a quadrilateral is a rectangle, then it has two pairs of parallel sides. So we are looking for a knot. So we have a knot here. We have a knot here. We have a knot here. Now the thing is here we have a knot in this side, but we do not have a knot. Like it say it has, so we are not denying anything. So this one is not right, and this one is not right. Now let's see which one is flip. So here we're talking about a rectangle. So rectangle and rectangle. And then we are talking about parallel. So here you see the parallel. Here we see the parallel. Now, as you can see, B is in the same order and D is flip. And we are looking for the contrapositive, and the contrapositive has to be flip. So B is wrong, and our answer is D. Now to 41. Given the statement, if two angles are not similar, their corresponding angles are not congruent, write the inverse, converse, and contrapositive statement. Now this can be tricky because we start with a not. And this is our starting point. This is not an inverse, this is not a contrapositive. This is our starting point, this is our condition. but we start with a not. So first, let's I'm gonna say, okay, we start with triangle. We start with similar, and we finish with congruent. Okay, let me put all the similar. So similar, 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 similar. Okay, and then for the congruent here. So here, 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 here. Okay, this is what we have. Let me write this better. No, I'm sorry for the cat. I don't know what happened, but I'm just gonna continue what I was saying. The first, the easiest thing is to make sure the order is fine. As you can see before, here, converse is the contrary. Is they flip, and the inverse is in the same order. So let's check for that. So we first have the inverse, so let's check they are in the same order. So in the inverse, they start with similar and then congruent. So similar, congruent, perfect. Here we have congruent, similar, so they're flipped. That's not what we're looking for. Congruent, similar, flip, not what we're looking for, and then similar, congruent. So we're fine with the order. Converse is opposite, so congruent, similar, okay. And here in this one, congruent, similar. Okay, I forgot to put this here. No idea. Either way, the contrapositive is also flipped, so it has to be congruent, similar. We have it here, and we have it at the end. So we're fine with that. Now let's start. The inverse, is the same order, but we are denying what the statement say, what the conditions say. Now we're starting with a not. We're starting with a not. Now we're not going to say not. That sounds funny, but we are not going to say not. So for denying that, we're just going to take away the not. So the inverse is it should be if two triangles are similar, their corresponding angles are congruent. We take out the not because we are denying. So let's see if two triangles are similar, their corresponding angles are congruent. Okay, like that. The inverse for these two triangles are similar, the corresponding angles are congruent. Perfect. The inverse is correct in both cases. Now let's check for the converse. The converse is the same, so we are going to give the or not because it's the same, but flip. Let's check. If two triangles are congruent, here we're missing their not. Then the two triangles are similar, we are missing it. We need to keep it. For the converse, we need to keep it. We're just flipping, we're not changing anything. So let's check this. If two triangles are not congruent, then the two triangles are not similar. Yes, that's exactly the same. We do not change the meaning, we just change the position. Now let's check the contrapositive. We change the position and the meaning, so we take away the not, and we start with congruent. So let's check if the corresponding angles are congruent. Perfect. We took away the not. Then the two triangles are similar. Perfect. Yeah, this is what we're looking for. D is our answer. Now, yeah, I think that's all for today because I don't want to start a new topic and leave it we don't finish it. So yeah, we're going just to do this next week and maybe start a new if we do have a lot of time left, start a new unit. So see you guys next week.